right. Hello. Good morning. Good morning, good afternoon, good evening, wherever you're watching us from. Hello, how are you? I am Aaron from Solace. Thank you for being here for yet another office hours. Today we're going back to the old school. We're actually not doing a themed office hours for about the last year and a half. Pretty much every episode has been a theme of some sort, like partition queues, distributed trace, event portals, event portal APIs, and so on and so forth. And this month we don't actually have anything specific to talk about. So we're going back to the old school, how the office hours used to be way back when, which was just kind of an AMA. Ask me anything. We're going to take a look at the Solace community and hopefully answer some questions live on air if there are people out there. And so to help me with that, I've invited two of my very good friends and colleagues to join me. Tom and Leah, I'm going to unmute you there. There we go. Hello. How's it going?
Hey.
Good. Thank
Hello.
you.
Thanks for joining me and helping me out here. So
You're lying, by the way. We've got so much to talk about.
We have a lot to talk about in general, but nothing specific, right?
Nothing specific.
Yeah. So why don't you go ahead and introduce yourselves? I mean, Tom, you've been on here a couple of times. That was November, I think, the last time we were on. But,
yeah, can't stay away, man.
Yeah. Leah, where are you joining us from?
I'm joining from Chicago. I'm on the same team as Tom, I think, although a different region, totally, because you're in London, right?
That's right. Yep.
Yeah.
Yep.
And I was supposed to be in Singapore, so we would have had a proper global coverage. But on the weekend, I actually flew to Vancouver, so I am coming at you live from Vancouver. It is 8 a.m. here on April 30th, last day of April. And Tom, I guess it's 4 p.m. for you. It's the
4 p.m. Lovely
May Day tomorrow.
Yeah. So, not in the UK, my friend. No, far too late for May Day.
I thought May 1st was a holiday. Oh, okay, all right.
No, following Monday.
Okay, all right.
Yeah.
So you get some time off, and Leah, do you get any holidays? Are you got anything coming up there?
Nothing for a bit.
Okay.
I think end of May is probably the next holiday.
Fair enough. All right. So, hello everybody. Thank you for joining. Tell us. We got some London, we got Chicago, we got Vancouver here. Tell us where you're joining us from. If you're out there and you're listening live, we are on YouTube, we are on LinkedIn, and broadcasting on the Solace community, solace.community, which is where we're going to be going to look at some questions. Say hello. Put it up in the chat. Take a look. Oh, there we go. Hey, Running Roach, my good friend. Hello. How are you? Hong Kong represent. Thank you for taking care of Asia. I missed you at the user group a couple weeks ago. Sorry I didn't get to see you there. So hope you're well, man. Hope you're well. So guys, let's kind of get into it. I'm going to share my screen here. Let's share the right one. Oh, look at this. It's a little bit meta. I'm on the community, and we could watch ourselves live here right on the community, but I think that would be a bit weird.
Might lose some CPU resources there.
Yeah, possibly. Yeah, some kind of weird loop. Abhishek, hello. How you doing? From India. Excellent. Thanks for joining. So this is what we used to do for the office hours. Just kind of browse through the community, find some interesting questions, and unless people had questions live. And I think we each kind of picked out a question or two here that we can ask. But if you're out there and you have a question for any of us or all of us, put it up in the chat. That's what we want to know. So here we go. I got a nice little scroller to get people in the mood. Put a question in the chat. Ask us anything about Solace, event-driven architectures, event-driven microservices, monitoring, best practices, all that kind of stuff. That's what we're here to answer, right, guys?
Mm-hmm.
Of course.
Yeah. All right. So I'm gonna pick an easy one to start because this is my show. So
ease you into it. It's 8 a.m. for you.
That's right. Yeah. No, it is a bit early for me. But so be it. So one thing that I see quite often, not only for users of Solace, but also Solace internal Solace employee people, when using our JavaScript API, oftentimes they want to send message as a text, like here it's a text string, it's XML, it's JSON or whatever, but they're actually publishing binary messages, a bytes message, you would call it in JMS. And that is because in JavaScript, it's actually a little bit wonky to create a text message, right? In JMS, you say create a bytes message, create a text message. It's quite clear what kind of message you're making. But in JavaScript, you can just take your string, your JSON string or whatever, and blop it as part of the binary payload of a message. So sometimes, yeah, as you can see here, this person's created a message. They've set the destination based on some topic, and they're setting this as a binary attachment. So this does not make a JSON text message, right? This is just a binary message. So if you're trying to read this with JMS or something, this is not going to work. So I just wanted to call out for the world that the way to make a text message in JSON is a little bit weird. Can you guys read that? Is that zoomed in enough?
Yeah, looks good.
Yeah, so you basically need to create, so text messages in Solace are actually structured data types. It's an SDT. We also have SDT maps. We have map messages, and we have stream messages. This is all thanks to JMS and the spec there that we kind of invented, I guess, these formats. Yeah, a text message is actually just a standard, is an STD. It's a SDT, a structured data type with a single field of a string, and this is how you create it. You say message set the SDT container as a type of string with the payload text. So if you want to, usually you don't kind of run into this until you start trying to listen with a different API. JavaScript to JavaScript, you probably won't see this as an issue, but when you're trying to read your text message in JMS, it's going to say that's not actually a text message. So
yeah, the other classic one is when you see some leading characters in front of, you're doing
printf
or something, and you see leading X0 or something like that, and that's the SDT delimiter at the start of the message.
That's right.
So classic one, if you're seeing some random, usually 2 characters at the start of your string,
2 or 3, yeah.
SDT conversion, right? That's where you often see it.
Solace JavaScript, weird stars. Yeah.
Yep.
So I actually made a post about this specifically because of exactly what you're talking about, Tom.
Yeah.
Is where you'll see these extra. Here's my string, but I have these extra weird bytes in front of it, right? And that's usually going the reverse. This is I'm publishing a text message with Java, and I'm listening to it with my with JavaScript. And what are these extra bytes? And that's exactly it. This is the SDT formatting. This is basically telling how large this string content is. And so, do I actually talk about it here? Yeah, here we go. So this is how you do it. You have to check the type, Solace message type. And so again, people usually run into this once they start mixing and matching different APIs, right? If I have JMS to JavaScript or the other way around, that's when you usually start to see this stuff. So
I've certainly seen it when publishing with Java and consuming with not Java.
Yeah. So different APIs have slightly different ways of kind of handling this stuff. But keep in mind, there are these different encoding types, and a text message is kind of a structured data type. Oh, hold on. I got to let my cat out of the room.
Just while Aaron's gone, if you think about it from why isn't the messaging handled like this? Well, it's not actually a messaging thing. It's a language thing. How do you do casting in your particular language? How do you type it in your particular language? And does that lend itself? So clearly in Java, it lends itself to being able to cast between the different message types.
Yeah.
How does that work in other languages? JavaScript's not strongly typed. So how do we do it there, right? You can just throw a text into a binary. That wouldn't work in Java. You'd get an exception, right? So that's the reason this happens. Don't blame us. It's languages.
So one thing, I started learning about the JavaScript API kind of way back when, and you could, part of the reason people run into this problem is, you can just say, get me the binary payload, and it would return as a string. It was just a string object in JavaScript. And so people would kind of not really key to the fact that this binary payload is not actually, it's a byte array. In 10. I think if you're using it's there's some factory setting. When you create your JavaScript connection, you can say this is a 10.5. It will return a byte array. I think it's called a byte array or a byte buffer or something. So that kind of keys you to the fact that this is actually a binary payload rather than a string object. And so maybe you'll then go and, need to say, okay, what is the type of this message, and, to get a string out of it. So if you're using the new Solace JavaScript, it helps you out a little bit there. So, I see that we have some.
Yeah, there's a question in there. Yeah.
Oh, sweet. There we go. Let's pop that up here. I'm not gonna. Here's
It's
a
a long
question.
one.
All right, Running Roach. We have an app component to read data from various databases and put onto Sol Cache. All right. I've heard that Solace now has DB connectors. Has anyone done a POC for connector to Sol Cache Direct? Oh, that's interesting.
Yeah.
This is covering up your face, Tom. Sorry. Can you see over the top? If you peek over the top, we can see. There you are. All right.
No, hang on. Can I do this? Can I do this? There we go. Look at that. There we go.
Oh, perfect. All right. Hey, so Running Roach, that's an interesting question. I'm kind of guessing that maybe your Sol Cache is storing kind of like start of day type stuff. So like when your apps boot up, they can get populated. I personally haven't played with any of the connectors. Have either the two of you? I mean, you're SEs, so
Yeah.
what are customers saying out there?
Yeah, I've played a little bit with the database connector. Just high level, just a quick kind of demo. So not in too much detail, but no, I haven't done this database directly to Sol Cache before. It's an interesting kind of data flow, if you will.
Yeah,
what about you, Tom?
Yeah, let's back up a little bit on this. If you think of it, Sol Cache, so that's our last value cache, and that's caching on. Yeah. So that's caching on topics, right? So it's holding the last n values on a given topic. So sure, you could use a connector, and obviously the connectors have got transforms in there, so you can transform to a topic, right? You can pick out the topic there, depending on the connector type, but in general. Right, and so you could use that approach to then pick out which cache element, if you like, you're going to fill out, right? So that's one approach to that kind of integration. But fundamentally, yeah, you've got to use the connector to publish to a topic, and after all, it's just going to end up as a topic, just like any other message event, right?
Yeah, like the connectors, obviously, yeah. So it's kind of from something to Solace, right? So if you're making a bridge or kind of an integration, you'll be, onto Solace and then off of Solace. And because Sol Cache is so heavily topic based, you would want to make sure that whatever connector you're using can take this data, whether it's a database, whether it's a file connector, and basically publish to a very dynamic topic so that, your Sol Cache is kind of popular. You're not overwriting the exact same thing over and over and over. It's a last value cache. So, I've seen in the file connector, I've seen some slideware that says you can configure it so that, if it's a CSV, you can actually build a dynamic topic based on, the column and the row, right? So you can kind of say, this is level 4, level 5.
The database connector is similar. It's based off of the database tables and column names. So yeah, you can use that to have that still fine-grained topic, and then if that's how your Sol Cache is consuming it, then that would be a pretty nice connectivity through the broker.
Yeah, important point. You're not going to be populating the cache directly. It's all done through topics, right? You are sending.
Yeah, it's a message. You publish a message. Yeah.
And the cache will listen to that, right? So it's not that you're going to pre-populate the cache or anything. It's all going to happen exactly the same way as you would normally do it, right? You're going to emit some events out, and the cache is going to listen to on whatever topics it's configured to and populate the cache that way. Yeah.
So the connector would be the cache hydration kind of mechanism. Yes, that's kind of what we're thinking of here. So yeah, so it could work. I mean, once it's a message on Solace, you can listen to it with whatever you want, whether it's your applications, whether it's your cache, et cetera, et cetera. The database connector is just publishing a stream of messages, and you can listen to them how you want. So it should work.
Just taking that thought forward, what that means is that you can't pre-populate the cache, right? So you can't set up a cache you're running at, say, application startup, and have late joiners come in and just read that cached value, right? You are actually going to have to send those messages out on the top, right? So you are actually going to have to effectively do. I don't want to call it a replay, but you're going to have to play the messages. Yeah, but it's important because if you're thinking of pre-populating a cache, you are going to get the live messages. You can't just assume that you're going to go in and do a cache request and get everything you want on startup, right? So you have to think about that. Yeah.
I think people that are used to Sol Cache are probably used to that kind of mechanism of to hydrate the cache, you have to publish the data, so it is going to cross the bus. Whether there's mechanisms built into these apps to say, don't listen to these messages, these are start of day messages, and then request afterwards. I don't know. But
maybe
there's no way to inject it directly into the Sol Cache. That's a good point. So
Mhm.
So when running Roach says Sol Cache direct, I don't know if that's direct messaging or direct to the cache. And so direct messaging, yes, no problem. Directly to the cache without other people hearing, probably not. Because they are messages and topics and messages. So cool.
Yep. Good question.
Yeah. Excellent. Thanks for the question.
I've noticed you got the integration hub up here. I don't know if we want to spotlight this at all, or if folks know about it.
I just pulled this up because we are talking about connectors a little bit, so just wanted people to know. Let me just move that out of the way there. Solace has been rolling out in recent days, in recent months, I guess, is this variety of connectors, this connector framework. I had Andrew McKenzie from our PLM team on several months ago, and he did a demo. There's a management component where you can actually remotely view and monitor the kind of status of the connectors that you're out there running. And so I don't know I guess the integration hub, this is all of our kind of connectors, whether they're self-managed, whether they're via RDPs and REST. But this is kind of the one-stop shop, right? For kind of coming and seeing what we have for these different integrations. Is that right?
Mm-hmm.
Yeah, that's true. Yeah, and some are built into the broker, like often the cloud native ones, so the AWS Lambda and the like. And then we've got some other connectors here that are not hosted on the broker, but they are built to integrate nicely with the broker, and then whatever the other component is. Yeah,
I don't have the slide in front of me, but I do remember that we have these kind of different kind of categories, right? The built-in, like the RDP, for example, right? Or the Kafka bridge, that's like a direct within the broker integration mechanism. Otherwise, our connector framework that we're talking about, this event-driven, is based on Spring, right? They're all Spring.
Yeah, they're all Spring. Yeah.
I think you can search based, I can't remember which filter it is off the top of my head, but one of the filters there allows you to search which one you'd like to go for. Yeah, this one possibly here, asset type.
Integration.
No.
Might be under the support piece.
Included, available, community.
Support available, so that's largely, that'll be a lot of the different connectors. A lot of these will run external to the broker.
These are more of the external ones, most likely.
And so like IBM MQ, I've worked with that connector quite a bit as well. This is the TIBCO EMS, which must be on another page. So these ones will largely run separate, and they're available from this website in a lot of cases, but versus the included, I think Solace included, those are largely built in
probably
into the broker itself.
RDPs and whatnot. So that makes sense.
Typically.
Right. So if you have something you want to connect to, this is probably the first place to go and look to see if we have something out of the box for you to try to integrate with. So please head over to Integration Hub, solace.com/integration hub. And if you can't find something or you don't know, head over to the Solace Community. There we go. Solace.community. I thought I had it as a ticker. There we go. Solace.community. If you want to find out a connector that maybe we don't have access to, right? Okay. What is next?
Running Roach has come up with a follow-up. Yeah. Hi, Stephen. How you doing?
Hey, Stephen.
As well.
Yeah. From Hong Kong as well. Excellent. Thanks for joining. It's in the evening over there. Hey, Tamimi, Vancouver. Yeah, it is sunny outside. Yeah, I'm happy. It was raining when I got here on the weekend, so today it looks like a beautiful day. So
a rare sunny Vancouver day, eh?
Yeah, this in the summer, Vancouver is spectacular. It is quite blue.
This is true.
It's not that hot. The winter time is very gray and rainy, and I'm not into that. So, Running Roach. Basically, we have users who are not really using messaging, but would think of this as a great way to show them end-to-end EDA. Okay.
Oh, interesting. Oh, should we? So on the connector page there, we've got some Debezium examples. So, look, if you're connecting to a database and you're thinking about EDA, you're probably thinking of something like CDC, right?
Yeah.
Change data capture. So when something is updated in the database, you then spit that out as an event or a message or whatever you want to call it, right? So that's probably more the way you do this. If you think about Sol Cache, what you'd be doing is almost replicating part of the database, right? You'd have some fractional shard of a database table in Sol Cache so that people joining don't have to hit the database for a query, right? That's an approach to eventing, but When you're thinking more about, okay, I've got some database entries and I want them to be available to people in kind of an eventing scope, what a lot of people tend to think of is CDC. So that's where you make an update to a database, you then emit that update as an event. That's one way of doing it. If you wind it back even further, why don't you emit the change that's updated the database? Why don't you use that as the event? Because you've probably got more context around it. It's probably more meaningful as an event rather than just, I'm going to insert, I don't know, Tom's new address in database row, right?
Yeah, there's different ways of slicing
sense.
and dicing it, I guess. But yeah, I mean, but whether like if they're not messaging users, using Sol Cache doesn't seem like the best fit. But like, obviously, having the change data or the updates to the database, as you were saying, emitted as events that you could then listen to, rather than having to go and query that database. That's what we're trying to remove, right? We're trying to remove that database as the central piece of the architect, like the dependent piece, right? If you can like have the database as the golden source, that's fine. But if you can listen to the events on the network as they go into the database, that's just a whole lot faster than going and querying the database every minute to find out, if something has changed or what the current status is. So, yeah.
Further follow up from Running Roach as well.
Oh yeah. Okay.
Yeah.
Let me go. We're having a conversation. Maybe I should just invite him on backstage and we can chat. So base correct from DB. So US not pulling from Hong Kong. Any delta from DB gets put into a topic with Sol Cache so people can send a message. But upon from Sol Cache.
Global cascaded cache sounds good.
Yeah.
Yeah.
So I mean, Solace does have our kind of global caching feature. Where the caches will actually talk to each other. You can have a New York cache, a London cache, and a Hong Kong cache. And, a Sol Cache user would query their local cache for this topic that lives somewhere else, and the caches will actually kind of send it amongst themselves, which is kind of a neat feature. Integrating database stuff into that could be kind of interesting. I mean, that sounds like something to watch.
Yeah, it'd basically be a publisher, right? And then you're consuming apps either are getting the live updates, the live changes from the database, or pulling it off of Sol Cache or PubSub Plus cache.
Yeah, I mean, the point with the connector is that if you're trying to populate the cache, like hydrate the cache, you would need something to orchestrate that, right? You need something to walk the tables and fill out the topics.
Yeah.
But if all you're doing is listening to changes, you could do it that way.
Most connectors that I've played with, so I've played with a few open sourcey things, they'll definitely have those kind of two states, whether you want to do kind of like the initial load, the table, and then it'll switch into kind of like the change data capture view where like it'll only emit the deltas. So you can like, as you said, there needs to be some process to kind of like get things initialized or hydrated at the beginning. So it kind of, I guess it would depend on the connector or the database or the technology that you're using.
Yeah, I was just going to say it depends on the database, right? Not all databases will support the kind of journaling you need for CDC as well. So, yeah.
Cool. All right, excellent. Thanks, Running Roach. It's a good question. Other people out there, if you have questions, look at this. We're having this awesome conversation here. Nick, hey, how's it going? Hope the rain stops soon for you. Atlanta, Georgia. Good to have you here. Thanks for tuning in. All right, let's go back to the Solace community. Let's throw up another. Leah, you asked. You had a good one here. Let me put that in there. So this particular user was kind of wondering, what they're running into some ingress discards, specifically message spool ingress discards. They were looking obviously at their stats. And they're wondering how to troubleshoot this issue. So, first of all, what are discards? Let's define those.
Yeah, so there's two types of discards. There's ingress discards, which is, of course, what this question's about, and then egress. And that's really looking at when a message is not accepted by the broker. So on the ingress side, it can't, typically it's talking about it can't go into a queue for whatever reason, or there might be some other reason, which we can go through some of what those mean. The other perspective here is egress discards, where maybe it is on a queue and it's discarded. And those are special cases for, message expiry, or redelivery attempts, those types of, or even administrative, you go in, maybe it's a test queue and you delete those messages. That's also represented in the stats. So I think the queue stats are honestly really helpful to understand what's going on with your messages and how they're behaving on a queue, or across the broker itself. It's not just queue related. And yeah, so we can see there's quite a few of them to go through, and we won't go through all of them, but I think it's good to talk through maybe some of the most common scenarios that you might see a discard. So,
well, this is so ingress is like it's messages going into the broker. So the broker is dropping messages that are trying to come into the broker. Almost always, this is your queue is full, right? Your endpoint is full, and the broker is going to send a NAC to your guaranteed publisher. Or in this case, as you can see, no eligible destinations, publishing to a topic that nobody's listening on, right? Those are probably the two most common, I would assume, right? What do you think?
Yeah, I would say so. Possibly publish ACLs if you're hitting those, but I think no eligible destination and something to do with the queue. Maybe it's shut down or full or whatever the case might be.
Right. Generally, unless you're publishing directly to the queue, the named queue object, and the queue is shut down, by default, if you're publishing to a topic that a queue is subscribed to and it's shut down, it kind of gets ignored. But there is that setting in the queue
by default.
You can say, even if it's shut down, that's an error condition, and send a NAC. And again, you can also configure in your client profile whether is it the client profile?
Yep.
Yes.
You can in the client profile you can say if I publish a guaranteed message into the broker and no one's listening on it, I want you to tell me. So that's where this no eligible destination is the flip case, where you're using the default, which is to not negative acknowledge on that. And so the broker, it doesn't have anywhere to put the message, so it's going to end up discarding that.
That's right.
And that's reflected here.
It's like in the most basic kind of publish subscribe system, the publisher doesn't care how many people are listening, right? 0, 1, N, a million, the publisher just sends its message. And, when doing guaranteed messaging, the acknowledgement that you get from the broker is just saying the broker has received it, but it's not telling you, who or how many people got it. But, if you're using topic routing for everything and nobody's listening to this guaranteed topic, I don't want it to be discarded without telling me. So this is like, you can say, if nobody's listening, give me a NAC. So, but regardless, this stat will be incremented whether you have that setting turned on or not, right? So if you are a middleware, an admin ops team monitoring your broker, watching these stats, and you see your ingress ticking up with this, that might be like, okay, I got some publisher publishing somewhere that nobody's listening to. That could be something to go investigate, right? So
yeah, if you're seeing that in production, wow.
Yeah.
Yeah. You probably don't want to be seeing that. Okay. Actually, you know what? Let me. Do I have a terminal? Just as a quick example, let me just log into my. Here, watch this. Show. What is it? Message spool stats. So these are actually all of the. Can you see that good enough?
Yep.
So take a look at all of these. These are all the different reasons why you can have the broker throw. And this is just for message spool. This is just for guaranteed messaging, right? You can also get blocked for ACLs or things like that, even if you're direct messaging. So the broker can throw stuff away. And as Leah was mentioning, you can have the broker can also throw away messages that are destined outbound, right? Egress.
Yeah.
And oftentimes it's usually just because they're expiring or TTL or maximum redeliveries has been attempted, right? So I've tried to deliver this message 10 times. The broker is going to discard that. So it's an egress.
And that's a setting on the queue as well. So by default, we're going to try infinitely, but you can set it and say, try X number of times. And if you fail, then do something with the message. And that, again, that's reflected here.
Yeah. So in general, you want your middle, your stats client. You want your kind of configuration or your monitoring, I guess, to be kind of watching these numbers. And if you do the, the detailed version, you can get a bit more information about, where are we? Right here.
There you go.
There we go. Ingress, egress, discards. Watch these stats. And depending on, if you're a direct messaging heavy application or you're a guaranteed messaging heavy application, some of these will be more important to you. No subscription match, again, is that kind of nobody's matching it, et cetera, et cetera, et cetera. So yeah, that's what all these discards are. I guess one thing to note, as from an API perspective, as a consumer, if you are too slow, you're a direct messaging consumer and you're too slow, the broker is going to discard things for you if your internal buffers, these buffers within the broker, fill up. For direct messaging, every client gets a chunk of kind of memory, and the broker tries to absorb bursts in messaging. But if you're too slow, eventually the broker is going to have to throw away stuff for you. So we'll call that where it would be this one, right? Transmit congestion.
Transmit congestion. So you're slow subscriber, right?
Slow subscriber. So this is direct messaging. Yep. You're a trading platform type application consuming market data. You're consuming direct messages at high volumes. If you start to see these, that means the broker is having to throw away stuff that you have subscribed to. And within your application, you can check on each message whether there's been a discard, right? There's a discard notification flag or discard indication flag, something like that. Yeah. And to signal to the application, the broker had to throw away some stuff. So if you're a direct messaging app, you should be checking that flag on each message to make sure that the broker's not throwing away stuff for you. So, right?
Yep. And to be fair, it's not necessarily the application that's slow. It could be some problems on the network.
Yeah.
I had one that was fun, an SFP that was failing. So it's like this application was fine, and then the little SFP that you plugged in this case into the switch, started to fail. And all of a sudden it's like, my application's slow. What the hell's going on? There's something wrong with Solace. It's like,
how did you?
Discards, and then,
were there like TCP errors on the connection?
Exactly, right. So this was direct messaging, right? So you go in and you start looking at congestion there, and you can see, okay, I've got transmit congestion. Okay, so then I'll go to a particular client, and I can see I've got TCP problems. So connections. Oh, he's a brave man.
That's I don't know if it's gonna fit.
Right, so in that massive text there somewhere, you can see things like you can see a good one is the receive and send queues, right? If there's stuff in there,
the send queue,
slow, right, and then you can start looking at things like, well, okay, so do I have fast retransmits? If I've got fast retransmits, what that means is that TCP has detected that a packet has gone missing. Ooh, that's bad news. We should not have missing packets. And what I discovered was a group of clients were seeing these problems, a random group of clients. But then you look at the client names, that's funny, they're all on the same host. So it's something to do with the host. So then you go on the switch and it's like SFP problems, right? Replace the SFP. Oh, we're happy.
Very networking, It's and people will blame the middleware, blame the Solace because things are going slow, and it often turns out to be something related, but not necessarily. So there you go. An SFP that's some good troubleshooting there, Tom. All right. I guess I'll leave my CLI logged in here just in case we want to look at that a little bit later. But all right. Oh,
we've got a live question.
Hey, all right, another question. Oh, okay. Let's start up here. Abhishek joining from Warsaw. All right, Warsaw, Poland. Hello. Thanks for joining. What's your question? Let's see here. Let's say we have a queue endpoint with name queue application 1. Yep. It has 2 subscriptions, A*C and ABC. Okay. It'll publish on ABC. Will there be duplicates? I think no. Correct. No is the answer. Yes, you can have whether you, the application, are subscribing directly to these topics, or you have a queue endpoint with the subscriptions on there for the guaranteed flow. It doesn't matter as long as it matches one. It can match 1,000 subscriptions, and you'll still only get one copy of it. So, yes,
we can segue there into the internal architecture where we don't store separate copies of the messages. We store references to them, right? So we're going to detect that we're pointing to the same message and go, "Hey, you've already got that."
Yeah,
you're all good.
Or you could also think of it as, topics are not like configured in the broker, right? So these matches are not happening independently, right? So if I have these two subscriptions, it's not like they each attract a message and then the consumer gets all of them, right? These are just matching rules on your single connection, whether it's your queue, or again using direct, and the subscriber itself is matching. So Abhishek, you can have as many subscriptions as you want. Well, within reason, you can have lots of subscriptions. They can be overlapping, and yes, it will dedupe. You'll only get a single message per
connection.
Yeah. Now, if you're using topic dispatch in C, for example, the overlapping subs will each get a callback. So that's once it gets to the application. That could fire off multiple callbacks inside the app. I guess
let's introduce topic dispatch. That's a facility inside the API. So this is not on the broker. It's inside the API where you can register separate callbacks depending on different topics, right? So you can have different pieces of code fire depending on the incoming topic. And that's kind of useful if you're subscribing to multiple topics and you don't want to have to do that topic matching yourself, right? But as Aaron says there, that's an API side thing. And the way that works is that if the particular dispatch topic matches, then we will always dispatch that piece of code, right? So, if you've got overlapping topic dispatches, that will cause multiple chunks of code to be executed. If you think about it, though, that's what you want. Because what you want to do is what you're saying to the API is, I want this code to execute for this particular piece of topic.
Yeah.
And that's kind of an always thing, right? I always want to execute this piece of code on this topic. So if that overlaps, then that's actually what you want to do. Yeah.
So this is built into the C API. The C API from Solace, the SMF API, supports this natively. I think C#, which is a wraparound C, exposes this. I'm not a.
If only there was a matrix in the documentation that told us about the features.
There is somewhere. Yeah.
There is.
But I guess I'll just quickly mention. I actually wrote a JCSMP topic dispatch. So I basically made some regex that does our topic matching, with our wildcards and the slash and the star and the different, that basically allows you to do topic matching in JCSMP. So if you need to do topic dispatch with JCSMP, you can check out, right now it's on my GitHub, Aaron-613, but I'm probably going to move it to Solace Labs at some point. That is
so it is available in C.NET, Java RTO, Java, JNS, and Python and Go. There you go.
Do you have, where's that? Can you put that link in the chat there, Tom?
Yeah. It's quite a useful one, actually. I often use that.
Is it in our docs?
Yep. There we go.
Yeah. I can't. Can I copy this text? No, I can't. That's annoying.
Just search feature support. API feature support, and you'll find it.
There we go. Ta-da! Look at that. All right. So what were we talking about? We were talking about
topic dispatch.
Topic dispatch. Where is it? There it is.
Yep.
So who doesn't support it? JCSMP, JavaScript. Anyway, we're getting maybe a little off the path here, but yeah. So Abhishek, the short answer is you're fine. Is if you have overlapping subs, no matter what, you'll just get a single message there. So cool, good. All right. How about Tom? How about we? I know you want to talk about some transactions. How about we throw up your question here?
Transactions. Gotta love transactions. Yeah. So there's an interesting question. It's quite a long thread about supporting transactions in C#. So rather than discuss the thread, which people can do at their leisure,
people can come here and read this if they want. You know what? Yep. I'll put the link in the chat. This is what we're going to talk about, but we're not going to read it verbatim. So if people want to go ahead and read that, there you go. All right. So what's this about in general? Let's
talk about transactions to start with, right? What is a transaction? Certainly in Solace, you've got two. You've got
session.
XA.
I assume we're talking session transactions here, not XA.
Yeah. So we've got XA transactions that we'll talk about then. That's a JMS thing only.
JMS thing.
Yeah. So here we're talking about session transactions or transacted sessions. Now, what they are is a capability that we've implemented in the broker that allow you to essentially bundle up a bunch of messages and consider that as an atomic chunk.
Yep.
What the hell does that mean? Well, basically what it means is you have more than one or more messages that you place on the broker, but they're only available once you hit a thing that says go, and that's called commit.
Now, you can do send and receive in the same session transaction. I guess I'll mention, right? So it's not only publish a blob or only consume a blob. You can actually kind of do a combination.
Mix and match.
Mix and match. Yeah.
Absolutely. So this is receive and transmit. So when do people use this? Well, when you should use it is when you've got an atomic blob that is over several messages, right? So that's when you
all to succeed or all to not.
Exactly. Yeah. Exactly. Now, the subject of this question is quite revealing to this, and that is, how do I speed this up? Right? If you think about it, you're doing quite a lot here on the broker. You're asking the broker to do a lot. As with most things, there is a penalty to pay, and that is that you're going to impact performance, because there's a bunch of administrative stuff that the broker has to do when you call commit to make sure that everything's working well.
It has to hold on to these messages that you've streamed in there, and you're kind of waiting before you hit the commit, right? Which kind of says, all right, now do it. So the broker has to hold on to these things somewhere.
And then the commit's got to make sure that every message that should have been written has been written or read, vice versa, right? So there's a whole bunch of state you've got to associate with it. So this is a expensive operation, right? And that's why the speed reduces. So where we see this used a lot is where people are worried about ordering.
Yeah.
Right. So here we go back to a whole discussion on ordering in guaranteed messages. Okay, so what's the unit of ordering in Solace? It's around the topic, right? So remember that when we're sending guaranteed messages, please always send them to a topic, and then we're going to have a subscription on a queue somewhere that's going to track those messages, right? Then we go into the idea of, okay, well, we're guaranteed ordering. How could we break ordering? Well, actually, there's a pretty simple mechanism for that, and that is, what happens if the queue fills up halfway through your stream of messages? You then consume some, and then more come in. What you're going to have is you're going to have some exceptions at the producer, right? It says, I can't persist these messages, and then more are going to be written. Okay.
If you're bouncing off the queue limits, right? Like if you publish a really large message and then some small messages behind it, maybe that large message will get knacked, and then the small message behind it will make it in. So that's where you can get into ordering problems. Although your queue is full, so that's just another problem in itself, right? But
So the standard answering from grizzled old messaging people like me is, well, make sure your queue's big enough, right?
Yeah.
Engineering, right? Now, the problem comes when you're dealing with iPads, right? Because all of this is a lot more difficult to deal with iPads. Some of the iPads don't like the whole knack kind of thing. So what they tend to do is close the session and restart it to make sure all messages are retransmitted.
Right.
And then you get into the situation of, hang on a minute. Well, maybe one approach is to only send one message at a time. This is what JMS does, right?
Your persistent JMS. Yeah, it blocks waiting for the confirmation from the broker.
Yep. Now another approach is to use transactions. Right. Because what you can do is say, well, I don't want to continue until this sequence of messages has been successfully written. Yeah. Right. Now these are all approaches that work. If you talk to people who are more from an eventing background, they're like, what are you doing? This doesn't make any sense. So people who are used to eventing, where you don't have the same kind of semantics that you've got in more traditional messaging backgrounds, they'll do things like item potency. So what they'll say is if you write the same event twice, it shouldn't have effects the second time. That's idempotency. Probably the most concrete way of doing idempotency is just to put a sequence number in the message. And then if you detect a duplicate sequence number, in the publisher, then you can determine whether it's a duplicate. You can determine whether you've got
gap detection,
all this kind of thing. Now, this is used all over finance, right? If you try and, if your ATM tries to say you've withdrawn your $100 twice, there'll be a sequence number in there, and the core banking system will go, "Whoa, I've got a duplicate. It's time for me to, throw that away." Right? So that is a super well-established method of doing it.
This is instead of using transactions as your kind of, you're right. Yeah. So these are different ways of thinking about how to kind of eliminate dupes, maintain order, et cetera, et cetera. So I guess transactions sometimes are a good idea, but maybe
transactions
not always. That's what
transactions you're saying? Transactions you get out a jail free card, right? I have a problem. How can I fix it? Hit this button here that does it, and it'll work. The problem is as soon as you start thinking about performance, that's when you've got to start thinking, well, hang on a minute, maybe I can't afford this expense of having something do this for me. I've got to do something a bit more clever myself. And that's where things like idempotency comes into play. And the reason for that simply is you're not having to wait for that settling period to make sure that everything's happened the way you expect.
I know if you're a JMS, specifically a JMS persistent publisher, transactions can actually massively improve your performance, because if you are just sending messages as a standard JMS, persistent publisher, it's blocking one at a time, right? The send call blocks until you get the ACK from the broker. But if you are publishing as part of a transacted session, then you can actually stream data into the broker. You can stream your persistent messages into the broker without blocking on that ACK. So rather than kind of like one at a time, you could start a session, transacted session, publish 20, 30, 50, 100 messages, stream them in, and then call commit. Specifically for JMS, all of our other APIs support, streaming persistent publish natively, but JMS does not. That is actually where you can get some really performant improvements. Is transactions can be actually more performant than not. So because of that JMS blocking.
That's a good point, but only in JMS and only because the JMS.
Only in JMS,
One spec was written badly, but bullshit.
There was a question way back when, and I actually saw. I went digging around and I found the post. Somebody was asking if Solace supports more than 255 messages in a session. For the longest time, transacted sessions were limited to 255 messages per transactions. And a couple of years ago, we opened that up. And I recently went internally and asked from some of our core engineering team if there are any caveats around that. And I got passed a large document explaining a lot of it. And long story short, yes, you can publish messages up to like thousands of messages in one transaction. However, if these are huge messages, that might cause some problems. If your broker is a very small broker, like you're using a software broker and it's like the 100 connection tier, right? The smallest size broker, that can cause some problems. So there are caveats around it. But short answer is yes, we can support more than 255 messages in one transaction. But if you have 1,000 connections all trying to do 10,000 messages in one transaction, that's probably not, you're probably going to blow up some RAM or something in the broker, right? So there are some asterisks in, yes, you can publish more than 255 in a transaction. So I just wanted to put that out there. Our good friend, colleague Nick was saying that he didn't know this was a controlled availability feature, but it is. So large number of messages in a transaction is something that Solace, we would like to vet and make sure that you're using the right broker and the right setup and everything. So
yep. We could talk about AD Windows, but Abhikash has got a question there, so maybe
he's got almost a request for you, Aaron.
Oh yeah, let me throw this in. Okay, Aaron. I watched your video for Kafka versus Solace. Yes, that's probably the most popular one out there. It's really helpful to know the underlying difference. Yeah, I mean Kafka and Solace both use a lot of the same words. Pub, sub, topics, event driven. And there's a lot of similar overlap in use cases, but completely different architectures within the broker, how we do this kind of, data distribution. Is there any plan for Kafka topic partitions versus Solace queue partitions? I tried to read the docs and got understanding, but not fully understand the concept. I've already used it. Cool. All right. So yeah, I mean, for people that don't know, Solace does. It was last year we introduced the concept of partitioned queues, where historically Solace had two types of queues. We had an exclusive queue, which was only one consumer had access to the data. So exclusive access to the data. That's where ordering, is guaranteed of that stream of data, right? The messages in the queue are going to hit only one consumer, so ordering is guaranteed. Or the non-exclusive queue, which means non-exclusive access to the data. You can have parallel consuming of the data, but if there's any kind of ordering requirement, the broker is just round robining between the different consumers there. So ordering is not guaranteed, right? You could have message one go to this guy and a related message go to a different consumer. And so, you want related messages to go to the same consumer. So that's why we developed I'm sorry, Tom.
Added support.
I'm just going to hide that for a second. We added support for partitioned queues. And obviously you can just go ahead and, Google this, partitioned queues. Now, this was obviously in response to Kafka's kind of capabilities of partitioned topics. Solace is never going to have a partitioned topic kind of, because topics in Solace are not actually configured, right? I mean, in the Kafka broker, the topic is both the destination, the addressing of the message, and also the storage, right? But in Solace, we've decoupled these two things. The queue is the storage, and the topic is the description of the message. And we do this via subscriptions. What do you want to attract to what kind of persistent endpoint? So in Kafka world, they've kind of glued these two things together, the naming of the data with the storage of the data, whereas we have kind of two separate things. But they are supposed to basically allow for the same capability, right? Multiple consumers in parallel consuming the data. Here's a little picture. Look at that. Can I zoom in here?
If you click on it, it'll go big.
Is it? Oh, okay. Yeah. Nice. So we would have it's technically a non-exclusive queue because we have multiple people listening to it in parallel. But internally there are these partitions which are implemented, in the Solace. Actually, they're implemented as exclusive queues, so that we have ordering on a per partition basis, and that ordering is determined by a key, or which partition the message goes into is on a key. And so this would be like your order ID, or the employee number, or the transaction ID, or some ID that you want to make sure that all related data, so like, all the blue data is definitely going to go to partition 0, right? And all the pink data is definitely going to, now that you could have interleaved data, that's fine, but we know that all the pinks are always going to get mapped to this guy, which means that they're always going to be, and each partition can have at most one consumer. So we're providing a parallel access to the data, but related data based on that key, in this case color, is going to be consumed by the same guy, right? Let me just go back and let me pull up the question here for a second. Well, I forget.
Okay, so I think it might be worth talking about the use cases for partition topics versus partition queues, right? So in the Kafka world, the whole point of partitions is that is the unit of consumer scalability, right? Basically, you map your consumers to consumer groups of partitions, right? And at topic creation time, you express via the number of partitions what you expect the consumer parallelism scale to be, right?
Yeah.
So if you think about it, that's kind of static, right? You're setting up this topic and you're saying here's the number of partitions on it.
Expected based on your peak loads and how slow the consumers. Yeah. Okay. Yeah.
Which you've got to calculate all up front.
Yeah.
So what you see a lot of happening, in fact, LinkedIn even wrote a tool called, I can't remember, begins with B, it's like Boston or something. What you tend to happen is that your architecture evolves. you tend to see, your scalability requirements change. Or as the consuming code changes and evolves over time, it begins to say, in this particular example, it begins to take longer to process blue for whatever reason. And so, the blue partition tends to get a lot more congested. And you end up in this situation where you've got to kind of look at the administrative stats on the Kafka broker and go, I've got to change these partitions to take into account all these effects. And then you get into this thing called partition rebalancing. And it's a pain. Now, if you think about Solace's hierarchical topics, the whole point there is that they're dynamic, right? So this idea of mapping is a dynamic thing. So what you can do in Solace, if you look at your normal non-exclusive queue, is there is no set level of parallelism in there. There's a maximum that you can impose if you wish. That's the connection count. Bind count. But you can actually have consumers come and go. Now, the problem with that, as Aaron mentioned, is that you then can't guarantee that a set of related messages go to that particular consumer. So that's
you mean during consumer scaling, like when you're changing the consumers around? Is that
exactly right?
Yeah.
Right.
Yeah.
Now, what
for non-exclusive queue. Yeah. Got it.
Yep.
Got it. Okay.
Now, of course, what you could do is you could use a element of your topic taxonomy to represent that similarity between a stream of messages or events, and you could do it that way. So actually, you could put your partition key in the topic if you want. Right?
That's the old school way of doing it. Yeah. Now it's all built in. Yeah. You don't need to.
Exactly. But there is one use case where that falls down, and that is where you don't know your partition ID on the first message. So a classic one of that is order ID. I want to initiate an order, give me an order. Your consumer goes, here's an order ID. Well, how do I map that to a topic, right? And how do I make sure that initial order initiation that doesn't have an ID and that then gets an ID all goes to the same consumer? And that's where this whole partition queue idea comes in, because it deals with that situation, right?
One other key difference I'll just mention here is in Kafka, if you have multiple apps, multiple consumer groups, multiple applications that want to read that stream of data, they're all reading it from the same topic, right? Which is a collection of log files. Each partition is a log file, and so even if you have a very lightweight app that is very fast, it still needs to connect to all of your partitions to read all of that data. So because they're all sharing the same data on the Kafka broker. Whereas in Solace world, this partitioning is on a per application basis, right? So if you have one app that's very heavyweight and very slow, it might need 10 partitions in order to kind of have the required amount of performance and parallelism. But you could have another app that's just a very lightweight app that can listen to the whole feed, the same topics, in a very efficient way. And so you might not even need to use partition queues for that app. So you could have a second app that just has its own queue with the same exact topics and or different topics, right? Because we have the topics and the subscriptions are separate from the queue. You could peel off different parts of it, right? So one app could be listening to the full feed and a second app might be listening to, just the Europe data, right? So you could change your topic subscription. Whereas again, in Kafka, everything goes into that one topic and everything needs to be read from that one topic. So a little less flexible, I guess, and on the Kafka side.
Yep. One last piece, partition queues, dynamic. You can change the number of partitions on the fly. Super fun.
It's easy to, but you still need.
Yeah.
You need to do a little bit of extra work to ensure that the partitions are drained before you change the number of partitions. And there's stuff in the docs. Yeah.
But fundamentally, it's still something that's dynamic, right? It's not.
You change a value and you click OK.
Yeah.
Exactly. It's quite fast. And I made a demo last year all about partition queues, and I played around with it a lot. And for the most part, you can actually change it dynamically, and I didn't see any gaps or duplicates. But to be correct, you're supposed to pause your publishers, let the partitions finish draining, change the number of partitions. From what I've heard from Confluent people, you can change it in the Kafka world as well, but most people don't. They say just make a brand new topic with a new number of partitions and switch over at some point. Simply because, they're log files, right? So it's not like you can drain your log files like you can in Solace. You drain your queues. You've read everything up until now. Switch your number of partitions, and off you go. So partition scaling is a little bit more dynamic in the Solace world.
So I think to sum up that answer, Adhikesh, there are still some differences because of the internal architectures, right? They're different internal architectures. I think the key thing to focus on is actually what are you trying to do there? Like, what are you using the partitions for? Come and talk to us. With that,
Solace Community, come in. These are the kind of things that we love to kind of banter around. We'll give you some different opinions. Solace.community. Yeah, it's right down there. All right, we're at the top of the hour, but like Stephen is a good friend, good customer. Let's do one more question here before we go. When having multiple consumers on a partition queue, it's related. Perfect, excellent. Where a hash key is well defined, as we hope our hash keys are, would the performance be better than the same number of computers on a traditional non-exclusive queue? Ooh, that's a good question. So, I guess the first thing that I was just to mention is a traditional non-exclusive queue, right? Is a round-robin distribution from the broker. It's kind of load balancing fairly evenly among all the consumers. If each message on that queue is completely independent of all other messages, that's when you want to use a non-exclusive queue, right? If ordering doesn't matter, that is what you want to use it for. Would it be better if things are well balanced and, so you have a non-exclusive queue with 4 consumers or a partition queue with 4 partitions and 4 consumers? What would the performance difference be? I think that's essentially the question, right?
Yeah.
I'm going to assume.
Hang on. Is that the performance overall? Is that the performance of the broker? Is that the performance of the consuming application?
Sure. Yeah. I mean, let's think of it. Yeah, there's where I would assume it's more or less the same. I would guess. It.
Okay, so I think you're right.
Okay.
On the broker, I would say the performance is broadly equivalent. Don't have any evidence for that at the moment, but just from a kind of architectural view of how things are working, I'd say it's similar. Yeah. However, if you take a step back and think about things as a whole, you're saying your hash key is well defined, but that doesn't necessarily. It would have to be well
balanced. Well
balanced is actually what you really need. So if you don't have any messages going into, say, the blue partition, because there aren't any blue partition messages, there aren't any blue messages to go in there, your performance as a system as a whole is not going to hurt the broker, but it's going to hurt your consumers because you're going to have your other 3 consumers getting very busy and blue consumers sitting there doing nothing. Now, the point with a non-exclusive queue, and this goes back to ordering, but the point with the non-exclusive queue, as Aaron says, it's kind of round robin. It's actually quite a sophisticated round robin, in that it looks how busy the consumers is and picks the least busiest consumer to send the next message. So
if one of these guys starts to slow down and his windows are closing, that the API signals to the broker that he's slowing down, the broker will actually skip him during this round robining.
It's not a perfect round robin.
Yeah. Which is good.
Which is a good thing.
Yeah. So the answer is, as always, it depends.
It depends.
We don't have evidence on the broker, I don't think. I'm sure somebody from R&D is going to scream at us now for saying this. I don't know of evidence on the broker, put it that way. I don't believe there should be much of an impact if there is. But my caveat is think carefully about your system as a whole and what you're trying to do. There could be a very large impact there if you're not careful.
The main thing is your number of keys and that they're well balanced, right? If I have 10 partitions and 5 keys, you are certainly not going to get, a nice spread, because at most it can go to 5 partitions, right? There's no way you can get that kind of, 10-fold parallelism. If you have 1 million keys, then you're probably more likely to have a nicely spread out group of messages.
But you've also got to balance your application performance on a partition versus the type of the amount of processing that those messages in that partition require. So if blue has to do an awful lot of work, right, you're going to want to balance your partitions so that you don't get many blue if you possibly can.
I like this diagram, some of it, but this is something that this looks like different types of consumers on the same partition data, right? I mean, I would typically you'd have different topics, right? I would assume everything in a partition queue, going like, even though it's different colors, they're all the same. It's all the same data, right? It's not like blue is heavier weight than pink.
Well, okay. A caveat to that is, let's imagine these are orders coming in.
Yeah.
And let's imagine blue EU orders. Maybe there's a bunch of GDPR checking you need to do on those before. So
sure, but put those on a different queue. Put have a subscription going somewhere else, right?
Sure,
I would assume that this data is all fairly the same.
It is the same data. It's just going to different locations, right? You see what I mean?
Yeah, but that if this is all GDPR, like, we don't control the hashing. Like, the Solace broker controls. There's no way to say this is all Europe data. Like, I mean, there's no way to know that, right? You can't place that directly onto the partition as of in today. This is based on the hash, which is based on. So I would say this should all be the same. The type of data within this queue should all be essentially the same type of data, because there's no way to say the partition 0, the blue data is all
okay, but it does raise the point.
It's typically, if you think of an order, like a commerce retail order coming in, you want to make sure all the events related to a specific order ID are received by the same consumer, and that's the point, right?
New order, change the order, cancel the order. You
don't want to cancel the order before you get the new order. That's obviously
because it goes somewhere else,
completely backwards. So you want to make sure there's ordering on a per order ID basis, but you don't really care which consumer ultimately gets which order ID. And so that's where I would say the consumer would likely be similar. It would be basically different instances of the same application. But and then in that scenario, your key is going to be the order ID.
Right. But supposing some order is, and to your point, Aaron, you don't know where a given order necessarily is going to go, right?
Yes.
But supposing
some orders may take more processing than others, but
and that's where partition balancing comes in.
Yeah.
Right?
Yeah. It's possible, that some types of orders could be very slow to do. Like a cancel might be extra work, right? Versus something like a new. So you're right. But ideally, this should be spread and distributed evenly anyway, right? I mean, that's kind of the whole point of there's no way to deterministically know this guy's always going to be overloaded, for example.
But it comes back to a point. If you can use non-exclusive queues, you'll get your overall system performance will be better, and that's because you don't need to balance partitions. It's
load balancing automatically. So Stephen, that's the final sum up is it not just well defined but well balanced. It's a very large key space, and it's hashing well across your however many partitions you have, and that's the biggest thing there, that you're going to see the difference in terms of overall performance. So hey guys, well listen, it's 10 after. I think we've been chatting long enough here. Thanks to everybody who tuned in for this kind of AMA style ask us anything. How about that? We got through quite a few questions. There's a few I had here that I didn't get a chance to talk to, but doesn't matter. Come find us on Solace Community if you have questions. That's where we hang out. Some of us more than others, but we have a lot to talk about questions. We do early access to APIs, all that kind of stuff. Guys, thanks for joining. Do you want to say any words before we say goodbye?
No, just thanks for organizing. Thanks to everyone who showed up, and we'll looking forward to the next one.
Keep asking questions, guys. We love questions.
Yeah. I don't know exactly. Oh, actually, I'm going to be on vacation next month. My mom and I are driving from Ottawa to Vancouver and back. So pretty much all of May, I'm going to be on the road. So I'm pretty sure I'm not going to be doing an office hours in May. Maybe I'll do it like at a motel somewhere. Who knows? And then in June, all of the Solace technical folks are going to be in Ottawa from across the globe. So, hey, you two, I will see you in Ottawa in June for our Tech Mesh Week. and I'll be back for my office hours at the end of June for the next one. So thanks, everybody. Thanks for watching. See you out there. All right. Okay.
Thanks.
Bye-bye.